All right, these are the 7.5 geometry video notes, day 2. So today we are talking about kites. All right, a kite is a quadrilateral that has two pairs of consecutive, meaning like next to each other, congruent sides, but opposite sides are not congruent. All right, so for example, here is a pair. These two lone sides are next to each other. They are touching, they share vertices, and they are congruent to each other. And then here's another pair right here, these shorter sides. They are also consecutive and congruent. But then you see the opposite sides are not congruent, or here and here, not congruent. All right, the kite's diagonal theorem says if a quadrilateral is a kite, then its diagonals are perpendicular. All right, so if ABCD is a kite, then the diagonal BD is perpendicular to CA or AC. All right, the kite opposite angles theorem says that there is exactly one pair of opposite angles that are congruent. Not two pairs, just one pair. So if quadrilateral ABCD is a kite, then that tells us that BC and BA are congruent. So we can conclude that the one pair of opposite angles is angle C and angle A. They are congruent. But angle B and angle D are not congruent. So only one pair of opposite angles are congruent. And where they are is the opposite angles are, you see angle C is in between one of each length of side, so like the one with the one line and the two congruent markings, and A is also between the side with the one congruent marking and the two congruent markings. All right, so this says find measure of angle D in the kite as shown. Well, so if we know that DE and EF are congruent and DG and FG are congruent, then angle D is between sides. Let's think of it this way, as like two different length sides, and angle F is between two different lengths of sides. Those are the two that are congruent in a kite. So I know that those are congruent. I'm going to call them X. So if I know that, then I can say that X plus 115 plus X plus 73 equals 360 degrees, because a kite is a quadrilateral, and quadrilaterals always have a sum of interior angles of 360 degrees. So X plus X is 2X, and 115 plus 73 is 188. That equals 360. I can subtract the 188, and I get 172, and then divide by 2, and I'm going to get 86 degrees. So angle D is 86 degrees. Okay, this wants us to find measure of angle Q and measure of angle P in the kite shown. So once again, this side that's 100 degrees, it is between the side with one congruent marking and two congruent markings. So it's the angle that sides of two different lengths are connected by. So it is congruent to the angle Q across from it that two different side lengths are connected by. So I just kind of remember like R is between sides of the same length. That's not one of the congruent angles. P is sides of the same length form P, so that's not one of the congruent angles. So what that tells me is angle Q is 100 degrees because of the kite opposite angles theorem. So then to find P, I once again know that if I add up all of the other angles, all four angles combine to be 360 degrees. So I know that if I have angle P, plus I already know about 290 degrees, if I subtract the 290, I'm going to find out that measure of angle P is 70 degrees. All right. In example 6, what is the most specific name for the quadrilateral that is shown? All right, so we've just got to look at all the details. All right, so what they show me here, when they show me this side length being like AE being the same length as EC, that's showing me that that diagonal is cut into two equal parts. And same thing with BE being congruent to ED. What this says is that the diagonals bisect each other. All right, and if we look at our various foldables that we've done, if we go look at parallelograms, that was a fact about a parallelogram, was on parallelograms, diagonals bisect each other. So the best name we can give it is parallelogram. We don't have enough information to give it a more specific name than that. Okay, if we look at B, we see that there are these two sides are the same length that are 50, and they're next to each other, they're not opposite. And then these two sides that are 51 are the same length. And once again, they're next to each other, not opposite. So that means there are two pairs of what we were describing is consecutive sides that are congruent. And also for the record, opposite sides are not congruent. So since it is like that, that would be a kite. We had to also state that opposite sides were not congruent, because if I knew that consecutive sides were congruent and opposite sides were congruent, basically I'd know I'd have a rhombus. Okay, let's look at C. C looks like a trapezoid, and so I'm pretty confident it's a trapezoid because it has one pair, exactly one pair, of opposite sides that are parallel. And so I definitely know it is a trapezoid. If I go ahead and I check the diagonals, so remember what it said about on the trapezoid. Let's see here. That was that the diagonals are congruent, then it's isosceles. So if I find YW, I'm going to do 75 plus 62. And that's 137. And then if I find Vx, that's 64 plus 80. That's 144. And so since diagonals are not congruent, that means it isn't isosceles. So it is just a regular trapezoid, non-isosceles. Okay, looking at what we've got going on D is we have, let's see here, one pair of opposite sides that are congruent. And so we don't have both pairs, so that can't give me anything like a parallelogram, a square, or a rhombus. I know one diagonal is bisected. I don't know anything about any angles. One diagonal is bisected. And I know one side is 9, but that really doesn't help me. So I don't have any information to show a parallelogram or any other kind of shape. So the best I can do is that it is a quadrilateral. Obviously, I know it has 4 sides. And so it is a quadrilateral, and that's pretty much the most specific name I can give it.